This is the student workshop area. A lot of mechanical engineering is to do with components and products, and although a mechanical engineer might not actually make them in real life, they may be just designing them and designing the process. Students are told and instructed how to use traditional manufacturing equipment such as lathes, milling machines and drills. These are traditional metal removal devices. A lot of mechanical engineering is actually moving to material addition, but these are traditional metal removal devices. Mechanical engineering at Heriot-Watt University, there's a lot of hands-on experience where students do laboratories, workshops and learn basic hand skills in manufacturing. It all culminates in 5th year when the students are given a very difficult specification to design, build and test a component. And this is one of the areas that students get access to. This is restricted for 5th year students doing their final master's year project. There's a number of hand tools available and they have technician support. But if we look across here, you can see collections of bits and pieces of students who are working on particular projects. They're beginning to take shape now, but a lot of them are still just bits and pieces ready to be put together. So these are a couple of examples of final year master's projects. This is an energy storage system replicated, if you imagine a mass, and when there's excess electricity, the mass can be raised, and when you want electricity, the mass can be allowed to fall. But this gives you an idea of a complex system that students have actually designed and built. It obviously needs a little bit more work still done to it, but it's in reaching its final stages. I mentioned that we had traditional metal removal manufacturing techniques. These are 3D printers where we have material addition. Most of these are plastics, where a lot of students can create nice little components that are representative of final components, and you can do some testing with these as well. It's an interesting subject because if you are making something, you have to make sure it's made to the correct size. So a lot of work is done post-manufacture to check how good a component has been made. So this is our coordinate measurement machine, and you can see there's a range of components here. This machine here will measure how accurately a component has been made. This has been made from a solid using a traditional metal removal, and this coordinate machine will follow the profile and check how accurately it has been made. It will also measure how accurately the circle has been made and whether or not the circles are concentric. If there is found to be a deviation in the measurements from what is required, then the manufacturing equipment would be checked and adjusted. Here we've got the head of a internal combustion engine, and the coordinate machine can be used to measure how flat the surface is to see if it's been warped. This is a piston. After use, a lot of pistons actually go from a circular shape into a slightly oval shape. This can be used to measure how round the component is. This is another component measuring device, not as complex, where basically it can be moved around to measure the profile of a shape. This is one of our flexible laboratory spaces. We share it with chemical engineering, and the whole idea about this room is it is not a fixed room. We have lots of experiments which are kept in the basement, are brought up and used for student labs. There's a lot of student labs that happen. We want you to learn the basics of engineering science and apply them in practical situations. So we have, this is a 3rd year design control experiment where we're trying to keep a ping pong ball at a certain height using a motor, so there's a feedback loop in there. So the students will design their control system and test it. These are a couple of our fixed labs. We use them in 3rd year as well for fluid dynamics. This is to measure the characteristics of pumps. So it's a basic simple system where a pump is used to push water through a circuit, and we can change the load and the flow by changing the valves, and we can see what the effect is on the pressure and the volume of fluid that is circulated. We have another facility out of this building which is also used for student access area, and the idea there is that students can design, build and test their own projects. So we deliver our syllabus, but we also give the students the ability to do what they want and give them resources to do that.